All good? Yeah? Cool. Hello, everybody. Nearly there. I think it's just one more after this, right? Then we're done. Enjoyed it so far? Awesome, yeah. I've never been to Australia in my life, so this is awesome for me. I'm really loving it. Great place. My name's Connell, here to talk to you about, migrating a feature from the monolith, the big bad monolith, to a shiny new microservice or service or of whatever size. Get the caveats out of the way, the little disclaimers. So this is our story, like how our team have done this for our specific case. I don't intend this to be a comprehensive guide for all possible features that you could move across, but hopefully there's some stuff in there that we can learn from our experience that I can share. So that's one caveat. Other caveat, if anybody was here for the karaoke yesterday and has only came here to see my wife singing, I'm sorry, this is just pure tech. This is just pure monoliths and microservices. So, caveats out of the way. When you're thinking of a monolith, your monolith, hopefully maybe you work in a monolith and that's why you've come to this talk, you probably think of something a bit like this. And I like to make everything about boxes and arrows, but with a monolith you've probably got hundreds of these. This is representational. You've probably got arrows flying everywhere and they're crossing over each other, and it's a big ball of mud. And it's really hard to find the boundaries within a big ball of mud because everything's just flying everywhere. Maybe this bit here, if we draw a box around those three, maybe that's what we're going to make into our new service. Or maybe actually it's this bit here. You know, maybe the stuff in the green box is more closely related or more coupled to the stuff in the purple box than it is to the red or the turquoisey cyany colored box. So where are the boundaries? So this was our first problem. In our case, we have this new shiny way we can make services. We know we want to break up our monolith because it's awful to work in, takes 20 minutes to build. But what is the service going to be? Where do we start? How do we find that boundary? So we need some candidates. You need some ideas, some bits of your software that could possibly be moved into a new service. And a candidate could be a bit of your architecture, like this, that already exists. Perhaps it's a class library or a set of class libraries within your solution, or namespace, something like that. Or you can think about it from a user perspective. Maybe it's a specific user journey in your application, or part of your navigation maybe. Like if you've got tabs, maybe it's one of the tabs. Thinking of a candidate could possibly move this into a new service. So we picked a few candidates and stuff we've been working on recently before that. We picked this one, which obviously, as you can tell by this awesome diagram, is our messaging system. So a little bit of context. So I work at a company called Stack Overflow. I'm hoping you're familiar with the site Stack Overflow, but you might not be familiar with the messaging part of Stack Overflow. So built into the Stack Overflow website is a messaging system. You know what a messaging system's like, this sort of thing where two people online can talk to each other and type to each other. So in our site specifically, it's moderator messaging. So the moderators can message the end users rather than the other way around. The moderators have to start these conversations and you get a little notification that comes up in the corner, all built into the site. This is usually going to be, if you've done something a bit naughty, perhaps you've pasted an answer in from ChatGPT straight into Stack Overflow to try and gain some internet points, and the moderators can message you and say, actually, that's against our policies. So you get this message. So that's our messaging system. But how do we know it's a good boundary? And perhaps you've got an idea in your head, the candidate for what you think could be a new service in your system. How do we know, or how can we check that the boundary, the candidate we've come up with, the bit of our software, is a good bit? So firstly, domain-driven design. I'm guessing you knew this one was coming, right? Domain-driven design. This isn't a DDD, domain-driven design talk, but for those that don't know, domain-driven design, fundamentally at its core, it says that the design, so your software design, in this case a microservice architecture, so your architecture, the way you draw those boundaries, those boxes, should be driven by the domains, the business domains, the problem domains. So it's saying that the shape of our problem, the shape of the thing we're trying to do, should drive the design of our software, our architecture. So there's lots of stuff about DDD. There's loads of other talks about DDD. There's loads of books to read. I'm not going to go into all of that. But very specifically, one thing from the sort of DDD literature that helped in our very specific case was it talks about the types of domains you can find. You can find your core domain, which is the main thing your company does that gives you a competitive advantage. So if you did that bit well, you get an advantage above your competitors. Then there are the supporting domains that sort of sit outside of that and support that core domain. And then there are these generic subdomains. Now, a generic domain or generic subdomain is something that we have in our business, but you'll have in your business as well. These are things that are found everywhere, areas of code or problem domains that exist around. And an example I like to give is users or authentication, that sort of area. I've worked in quite a few microservice architectures where we've had a users service or authentication service or something along those lines. And that's because it's a generic thing. Like it's not specific to your business. Lots of people need authentication. And the thing about generic subdomains is there is, I'll say always, maybe almost always, an off-the-shelf product that does this for you. So in the case of authentication or users, you've got Auth0, one of the sponsors here. You've got Azure Active Directory. These are off-the-shelf products that do that generic thing for you. So somebody's already drawn the boundary. Somebody's already decided, that's what I think this domain, that's what lives in there. So in the case of messaging, you can think of tools like WhatsApp, like Slack. These are messaging products that somebody has said, this is what messaging is. So when we're trying to break out messaging and we've got to reach a tiny decision where it's, well, does this code belong in the monolith or do we bring that into our new service? We can ask, well, would it make sense to bring into a product like WhatsApp or Slack? Does it make sense to be in messaging? So somebody's already defined the boundary. Somebody's already drawn it for you. So that's domain-driven design. That's one thing from domain-driven design. There's lots of things in that. You can do context mapping, domain storytelling. You can do event storming. I'm not going to go into those things. But if you want something a bit more lightweight that doesn't involve reading loads of books, and you can Google this exact phrase, green ticks. Sorry, these things are not binary. These things are, I'll say, green tick for messaging, given our case, even though it's moderator messaging. It's kind of in the right area. The fact that messaging products exist tells me that this could be a good thing. But it's not yes or no. It's like, yeah, OK. Messaging sounds like it could work. Now, if you want something lightweight, Google this phrase, independent service heuristics. It brings up a GitHub repo, which is just 10 questions. It's just a markdown README, which is just 10 questions. So much more lightweight than domain-driven design and reading all that. Just 10 questions you can ask about your candidate. Could this be an independent service? Now, I'm not going to list all 10, but there's a bit of I imagine, a Venn diagram of these questions. And they all center around this core point, which is, could you run your candidate as an independent software as a service product in its own right, like a little micro business within your business? Does it make sense? And to go back to our authentication example, I like to invent this fake story in my head that Google, when they are making googly stuff and they needed authentication, they had a login with Google button that they needed to log into, Google Docs and all that. And someone said, well, why don't we make the button itself, the login, the authentication, its own product in its own right? It's its own system. And now other people can have a login with Google button for SSO on their website. I totally made up that story, but I like to think it's true. It's this idea, can you do one part of your system as its own product? So, to not go list all the 10 questions, with messaging, one of these questions is about the brand. Can you imagine a successful marketing campaign around this idea? Can you imagine advertising this candidate as its own product? So in our case, Stack Overflow mod messaging. Can you imagine Stack Overflow mod messaging? And it's got our little logo on it, and it's in our colors and brands, and we've got adverts about it in the bus stop or wherever you see adverts nowadays. And I mean, I don't think that's too ridiculous. I mean, we're not going to do this. There's no plan to sell this as its own thing, so you can put your money away. I'm sorry. But the idea, I don't think, is too ridiculous. If somebody did the business analysis and came to me and said, we're going to make loads of money doing this, maybe I'd believe it. So I'll give that brand. Yes, I can kind of imagine selling moderator messaging as its own product in its own right, outside of our main business. There's another one, that team resources. So this is basically is it too big? Like, can one team support this and maintain just this product in its own right? And in our case, we were already doing this. We were already working in the messaging area within the monolith. It's not too big. One team can manage it, so I can give that a tick. It's a web application. We don't need much extra infrastructure or anything. And then team ownership. So can a single team own like the destiny of this product? Can you prioritize the features yourself? Could you give this area, this domain, I'll try and avoid the term domain, but can you give this messaging world to a product owner or a product manager and say, you're in charge of prioritizing the features now? And yes, we pretty much were doing this anyway, but to give you a little bit of context around how the teams are structured within our company, we have a private offering called Stack Overflow for Teams. I'm not here to sell you that. I work on the public side of things. But in that private world where you can basically host your own instance of Stack Overflow and do your own Q&A about your own architecture and get your own reputation points within your own company, you don't need messaging. It doesn't exist because you'll just use whatever you use. You Slack or Microsoft Teams or whatever it is you use to message people within your company. So you don't need another messaging product built into your Stack Overflow. We've got some other teams that look after the API, for example, so like a REST-ish API. And as far as I'm aware, there's no messaging in that world either. So this is only a public platform. We can prioritize the features. We don't need to ask other teams how it's going to affect them. We have the autonomy. We have the ownership. One team can do this. We can run this. And then last one I've picked out, because there are 10, was team independence, which I'm kind of seeing as the reverse of the ownership side of things. So this is rather than other teams, or us depending on, no, rather than other teams depending on us and our impact, this is, can we get stuff done in this area without having to constantly ask other teams for help? So are we dependent on other teams? Do we have to raise a help desk ticket to spin up some infrastructure every time we want to get anything done? Or ask the data team of something? So can we get stuff done in this area ourselves? And yes, like I say, infrastructure it's a web application. Maybe we need something in the future for push notifications, but in general, yes, we can get stuff done without having to depend on other teams. Okay. So the astute among you may have noticed the last three there are all about the team. And that's maybe, this was written, or the writers of Independent Service Heuristics are the writers of a book called Team Topologies. But that aside, I don't think it's a coincidence that this all seems to be about the team. Because this guy, Melvin Conway, once said that, see if I can get this right without looking, organizations which design systems are constrained to produce designs which are copies of the communication structures of the organization. How'd I do? Nice. I've done it a few times now. I'm getting there. This is Conway's law. And one of the things, Conway's law, I know, is a law. So it's not a design pattern or a practice or a principle or something that you can choose to adopt. Conway is saying this is a law of nature in a way, like Newton's third law, or is it Goodhart's law or something like that. This is an observation about a thing that happens in the real world. Conway's law, not Conway's pattern or something like that. And it makes sense. It makes a lot of sense, the way you talk. So Conway was talking about like governments and generally organizations, but applied to a software organization, the communication structures are our teams. They're how we talk to each other. You might have a daily stand-up with your immediate team, but then maybe a weekly meeting with your department or however. Your structure, your org chart, essentially, is the communication structure, or ends up being the communication structure. Things like time zones might have an effect on these things as well. And that structure is the design that we produce, is Conway's law. And the design is our software design, our architecture. And this makes sense. The example I like to give is if you have QA engineers or testers writing automated tests, if you put all of them in your organization in one team, and they talk to each other daily, and they have their daily meetings, and they're pair programming with each other, they inevitably build this awesome test suite, this automated test suite, and there's loads of shared helpers to do the arrange phase and the assert phase, and it's all very unified, and maybe it runs separately in its own pipeline against the rest of the application, and it's a nice unified test suite. But that's a very different architecture than what happens if you embed a QA in each team. Now their daily conversations are about, well, with the domain experts and with the developers that are working in that specific area. Perhaps they even write different languages. So these tests over here might be written in Python. These over here might be in TypeScript. And now you don't have a unified test suite, but the tests are more coupled to the domain and more coupled to the area they're in than they are to the test suite as a whole. And that's Conway's law in action. All we've done is change the shape of the teams, and we've ended up with a different architecture for our test suite. And the same thing if you imagine front-end engineers. If you put all of your front-end engineers in one team, you inevitably get like a single-page application, lovely unified front-end that talks over APIs to this back-end. And the communication with the back-end team may be, rather than daily conversations and this understanding that we have through working with each other daily, it might just be through a Jira ticket. It might be the abstraction that you've made in your head, and you've had to sort of reduce some of the complexity to write in a Jira ticket, and now you've got an API call based on that Jira ticket. That's the communication structures. Yeah, sorry, I can talk about Conway's law all day. I do have other talks that go into that in more detail, but I won't rant about Conway's law for too long. Let's move on. These are Postits. So we've got our domain, we have our team, we have the idea of moderator messaging to be our domain, we have our team that are going to look after it. We need to know what it's going to do. What is our new service going to be? These are all user stories, Postits that we stuck on a virtual wall. And we arranged them into, this is a story map. So one of my talented teammates introduced us to this idea. I've never done this before, but I think you're meant to do it before you embark on a big project. You work out what it's all going to do. Obviously, in our case, the monolith already did this stuff, so we're mapping out what we could move out. What is the messaging world or domain? And it's all this stuff. You've got user stories here for moderator can start a new message from a template. User can reply to the moderator. All these user stories arranged into tasks or activities. And what we don't want to do is build all of this, like stick all of this on a sprint board or a Kanban board, move everything to done, and then say, great, we've built this new product, and then turn it on in like a year's time after all this work, and best case scenario, nobody even realizes we've changed anything. We want to do it more iteratively. So we want to pick, and we picked this vertical slice, this set of stories, this one feature, and we're going to get this one feature into production live in a new service and leave the rest of it in the monolith for now. We're going to do it bit by bit. We're not even going to touch the rest of the stuff that's just working in the monolith. Then we can get that live first. So this is called the strangler fig pattern, which is a tree metaphor. I don't know much about trees at all, but there's a thing that strangles, I think is the verb, the tree. I think the metaphor is the tree is meant to be a monolith, and eventually your services are doing all the things the monolith does, and the host, the monolith, ends up dying because it's not doing anything anymore. So yeah, iteratively moving features into a new service. Strangler fig. So we've picked this feature here. This, as of course you can tell from the Postits, is our latest messages widget. These are the features involved in this widget, which obviously you don't know what they are. So allow me to just draw what that looks like for you. So you've got the site, Stack Overflow. You've got our lovely logo in the corner there. You've got the nav bar, the sidebar on the left-hand side. At the top, you've got the search box. You've got the bit where your user profile goes if you're logged in and shows your reputation and your lovely gold badges. And then from this point, you can see why they don't let me anywhere near the designs here. You're probably used to seeing a question and answer at this point in the middle of that page. But if you were a moderator, you can navigate yourself over to the Mod Tools dashboard. And I'm sure you've seen dashboards before. If you've got observability, you've got Datadog. The dashboard just has widgets showing what is happening around the site. We have this flags widget, so latest flags for when you flag a question. You can say, oh, that's closed, or you can say, want moderator attention. There you go, moderator attention. It appears on the dashboard there. And then there's this latest Messages widget, which I've put in blue because that is our Postits. That is the feature that we want to move across. Currently in the monolith, we want that to be in a new service. And then we've got some other widgets that, for the purposes of this talk, we don't care about. I have to caveat that. Once I just said, oh, which we don't care about, and it sounded like I was saying the company don't care about this stuff that we maintain. No, for the talk, we don't care about those widgets. So why the blue box? Why this widget? Why didn't we pick like the view thread, like when you're looking at a thread, if you imagine your WhatsApp thread with the messages on it? Why did we pick this? And there's a few reasons. So firstly, we want to reduce the risk. So we are the first, this is the first thing we're moving into a new service, and we know that comes with risks. Things might go wrong. And the reason this reduces risk is, firstly, it's non-critical. In terms of the messaging world, there's other ways to get to messages. So you receive an email, you can click through from your email to get to the threads. I think you can get there from the user profile as well. So if this widget stops working, it's inconvenient. The moderators might have to do a few more clicks, but it's definitely not the end of the world. Things still function. So if it goes wrong, non-critical. And secondly, it's relatively low usage for the moderator things. This is on the mod dashboard. So by very virtue of it being on the mod dashboard, it's only available to moderators. The end users who are receiving these messages never see this. So there's a small subset of users can even see this. So if it does go down and break, fewer people know about it. So that's reducing risk. And then we want to simplify the development for us. Like, we know this is going to be difficult in some ways, and we want to make it easy for us. We don't want to have, as we're starting a new service and the first ones to do it, we don't want to have the inevitable 20-point story in the Jira backlog that's just called setup foundations or setup framework or something that the product manager doesn't care about. We want to make those foundations simple, even ignore some of them if we can, and get to them later as we would do this iteratively. And this widget is read-only, so it's just a view. You can't delete messages from here. You can't, anything else. You can't rearrange them. You can't reply to them from here. It's a read-only view of the messaging world, which I'll get to this later, but syncing data means we only have to do it one way. We only have to read. Also, I like this one. It's an entry point into the user journey for messaging. So you can get to this page, and you can click through from the messages. You can click through to the latest message and then open that thread view. But there is no other one of those Postits. There's nothing that links back to this page. It's always the first thing in a user journey. You can navigate from here to other messages, but there's nothing on a message that says, go to page 5 on this widget, for example. So it's an entry point. And again, I get to some of the technical details of why that simplifies things later. So that's the feature that we picked. And now we've got our first technical problem, shall we say, first coding problem, which is, this is the UI. How do we get one bit of the UI, just the blue box, to be hosted in a separate service, an independently deployable separate service? Because that's the dream. This is what we want from microservices. We don't want to have to wait 20 minutes for our monolith to build. We want to be able to just deploy a change to that bit of UI without affecting the rest of it, which is hosted in the monolith. So how do we do distributed front ends? How do we build micro front ends, this is called? So we could have done like an iframe. We could have put a little iframe there and just tell the browser this is hosted on a different website, basically go and grab that other website and put it there. We didn't do that for reasons. We did what we called the embeddable UI component, which is a fancy way of basically, web components, or if you've worked in Angular, React, everything is just components all the way down. So you have a button component, text box component, and then maybe there's a component that combines the two. One place I worked, we had atoms, molecules, and a design system like that. It's all components. We figured, can't we have a latest message widget component that somebody can drop into their page? It's just a component, like it is a React component or an Angular component. So what does that look like from the monolith's point of view, if that makes sense, if we personify the monolith? How do I get this widget into the monolith from the monolith's code? Or actually, forget even the monolith. Remember, we're doing this independent service heuristics. We're pretending we're going to sell this product to anybody who wants to buy it. So let's say you work for Reddit. Do you work for Reddit? No, if that ever worked, that would just be amazing. Your community website wants to embed this component into your page. How do you do that? Well, first you need an empty div. So you just go div id my awesome div. This is just empty, it doesn't do anything. Then you have a script tag. And I put type equals module here. So this is an ES script module, which allows me to await import. So now I can declare a constant or declare a variable and say import that from an external URL, which is going to be hosted by our service. And that component.js file, a little sidetrack here, is just pure JavaScript. There is no framework or anything behind this. We build it in Svelte, which is another front-end framework. I don't know if React or Angular work like this, but Svelte compiles it down to pure native JS. So the contents of that JS file is like a minified file with things like document, create element in there. So you don't need to be running Svelte in the host here to work. It's just any browser window. Unlike jQuery, which is another one I've been familiar with, like if you were to download a jQuery plugin, like the date picker or something, you'd need to be running jQuery in the browser for that to work. But here, you don't need to be running Svelte. Anybody can just import this JavaScript file, put it into this constant. Then you need to go and get your div. So document get element by ID, my awesome div. Again, it's just plain JavaScript, nothing fancy going on here. And then there's some syntax to combine the two together. We've chosen a class that we kind of knew up here. We've got an object that has arguments that we can pass into it, just as an example. But some way of saying render my component, the JS, onto my target, my empty div. Could be a function, however you choose to do it. And that's it. That is the code from the point of view of the monolith or your community website to get the widget on your page. But what's going on there? So this is a sequence diagram. I'm going to draw a sequence diagram. I love a good sequence diagram, where we've got three parties involved: the browser, the monolith, and the new service. What happens when you see that code, right? Your browser goes to the monolith, get me /dashboard, the moderator dashboard. And the monolith returns 200. OK, here is that HTML that I just showed there with your empty div. So we can render this much so far. And note, if I put a big red circle around that, empty div. So at this point, the browser has just got an empty div where the widget should be. But also in that HTML that was returned from the monolith was our await import. So now the browser jumps straight across the monolith, straight to the service and says, get me component.js. And the service goes, yep, 200, OK, here is component.js, gives you some JavaScript. We could have done like a server-side rendered thing here. So imagine the pink service application there is a Node.js backend, and we're doing some server-side rendering, and every time you request that, it's a different JavaScript file that has different contents. We didn't do that either. We went for the single-page application approach, or like, I don't know if it's really a single-page application, but it's a static JS file. That is just the app. So if you imagine like the app on your phone, the bits that are on the phone in that JS file without the data. So at this point, static JS, we can render about this much. We can put the little messages thing in the corner. We can maybe make it the right colors. But we've got no contents. We've got no messages to display here. Within that app code is a way to go and get that. It's just a fetch request. So it goes to an API, which is also on the service. Go and get me the messages that I need to display. Get me the JSON. So it goes 200, OK, here is some JSON. And now my component.js file knows how to render that so we can put the contents in there. And that's the sequence diagram. That's how the conversation is happening here. Note that the front end and the back end are now on the service for the messaging. We can make changes to both how the data is there, or the front end. Both of them independently deployable from the monolith. But again, the sharper ones amongst you might be looking at this and going, that's not going to work. And you're right, it doesn't work exactly like that. Because if you've ever moonlighted as a front-end developer in a distributed system, you would have come across the dreaded cause error when I try and make these cross-origin requests. And that's not too difficult to get around, change some settings. But even if I do, even if I'm able to make cross-origin requests to my service, that last call to get the JSON, to get the contents, is just an API call. I need to authenticate that. I can't just have an open endpoint that's all the messages that moderators can see. I need to know that you're a moderator. I need to know that you're allowed to see this. And the first conversation to get the dashboard does that because it's on stackoverflow.com. We pass up a session cookie. Your browser gives it a session cookie, so we know who you are. But even if you get around the cross-origin stuff, we don't send the cookies from stackoverflow.com to a different domain. And even if we did, we don't understand, it's just a string. We don't understand the contents of this cookie in the service. So what we should probably do to authenticate this is going back to our user service idea. Auth0 or whatever we want to put behind it, we could make a service that is responsible for generating tokens, and we can give the browser that. It can use that token to make the request, and it can put it in the authentication header. Great, we should totally do that. That is definitely the right thing to do. But we didn't do that either. Like I say, we don't want this 21-point story that's going to be set up foundations. We are eventually going to need a user service or something like that. But for the purposes of this, just to get something live, we just put a proxy in the monolith, which is just an ASP.NET controller, just a normal controller that when I send it anything, so now my browser can go /API, or the root is like /myAwesomeService, whatever, /anything I want, so /AwesomeService, /API, /messages, and the proxy will take everything after the slash and forward it downstream to the service. But this time, the reason this works is because the proxy is on stackoverflow.com, the browser sends up the session cookie to my controller, and my controller knows who you are. I've got a user object there, so I can take some of that information, your user ID, some contextual information, like whether you're a moderator, and put that on a JWT token, and then send that on the downstream request in an authentication header. And now my service can understand the JWT token. It knows who you are. It knows you're allowed to get that JSON. And it can go, yep, 200 OK, here is the JSON. And the proxy just forwards that back onto the browser, 200 OK, there was your JSON. And now we can render the contents in the widget. And this works. This is now a functioning microfrontend and backend. But we didn't stop there. Because although this works, we thought, well, if we've got this proxy that is /myAwesomeService / whatever I want, then why don't I just use the proxy for the component.js call as well? Now, OK, that doesn't need to be authenticated. We don't need to be passing the cookie or the authentication header to the service just to get the static JS file. But why not? Now, if you're looking at this diagram, there are no calls from the browser straight over to the service. Everything goes through the monolith. So actually, my service doesn't even need to be on the public internet. I can put my service on a private network, and there's a little bit of extra security there. Only the monolith can even access the service. OK, so there, here's the sequence diagram. That's how the communication is happening. Let's just have a little look at this last request there. I said it was to get the JSON, the contents, of everything that's going to be in that widget. So everything in that widget needs to be in that JSON response. The widget, to give it a little bit more detail, looks a little bit more like this. It's a bit better than that, but it's better than some lines. So JSON needs to contain everything on that page. So what's our JSON response look like? Well, square bracket, it's an array. One for each message. So each message is an object, so squiggly brace. And then we need the username, so just a string, going to be in our JSON. We need the picture, so just a URL to your avatar, so whatever.png, .jpeg, .gif, insert your favorite image format here. Then we need the date, so we just ISO date format string in the JSON. And then this excerpt, which is like the first 100 characters truncated with a ... of the latest message. And that's it. That's all the information that we need. Well, actually, there's some IDs for some links, but that's the only things that are displayed on the page. And the problem is, this response, although it's going through that proxy, the response is generated on our new service, on the back end of our new service. And all of that data, the name, the image, the date, currently in the monolith. And because we're only moving this one feature over, and we don't want to touch any of the other features in the monolith, then the data is going to stay in the monolith. So how do we get it in the service? How does the service respond with that information? So the instinct is to say, well, I'll just go and grab it from the monolith. Maybe I'll make an API call. Maybe I'll grab it straight from the database. But let's just have a look at what that looks like. Remember, we have this proxy. So the browser is going to the monolith, get me the message JSON. And the proxy in the monolith is going to the service, get me the message JSON. And now we're saying that the service is going to have to go back to the monolith. Can you just get me that data? So that the monolith can go 200 OK, yep, here's that data. So that the service can go, yep, 200 OK, here's that data that you literally just gave me, so that it can forward back. No. We're not doing that. Not just because it's silly or inefficient. I mean, we can get around inefficiencies with caching. Maybe it's like a lazy load type of thing. But then cache invalidate. How do we know the data hasn't changed? We didn't want to do this, or shall I say I really didn't want to do this because of that, because of this circular reference. Now, this is the part, this is quite opinionated from my point, and not everybody agrees with me on this one, but I didn't think we wanted the circular reference. And what do I mean by circular reference? Firstly, the monolith knows where the service is because it needs that URL for the proxy to send stuff down. So in its config, there is a URL for the service. It needs that JDBT key so that it can sign the authentication header, so that the service knows who it is, or knows that it was actually the monolith. And there's like it understands the service's contract. It understands its endpoints. It knows that it wants this JDBT thing. There's a reference and like an understanding, contract knowledge. So what I'm thinking we should avoid is the opposite as well, having the service know where the monolith is and understand. So we don't want it to make a call to the monolith's endpoint, because then it needs to understand that the monolith's endpoint is there and understand what properties the monolith is expecting. And for reasons, like if this was a modular monolith, for example, and you weren't doing a distributed system, and these were two projects, and you tried to make them dependent on each other, your compiler just says, no, I can't build that. I don't even know what order to build these projects in. So you can't even do this if they were projects in a solution. Even though you technically can do this over a network just by giving URLs, I think it's too tight coupling. You get versioning problems, and there's a few real-world scars that I've got, which I can try and convince you. What about your other host? What about your community website? If you're going to embed this, if we're going to say anybody can essentially embed this component into their website, it's a bit silly that you can embed that, but then the service is programmed to call back to our monolith. It would just return the wrong data. That doesn't make any sense. So now we've said, so now we can't sell this as its own product because it's coupled, it's dependent on our monolith. But I get it, that's just a thought experiment. We're not actually going to sell it as its own product. So, okay, fine. We don't actually have this problem. But actually, at our place, we do have multiple monoliths that are calling out to the service. So we are going to have this problem. Even though we are our own customers. We are our own customers 150 times, as it happens, because we have other Stack Exchange websites. For those that don't know, Stack Overflow is a Q&A site about programming, but we have clones. It's part of the Stack Exchange network where we have sites. Superuser is about IT stuff. And we have 150-ish of these. There's one about chess. There's one about the English language. One about music theory. There's one about world building, code golf. All of these things are separate Q&A sites with the same sort of layout as Stack Overflow. And they all call into this service. And what we don't want is somebody to be a moderator on the chess website, and they go to their mod tools, they look at this latest message widget, and it calls back to the Stack Overflow and gives them the wrong data, the wrong messages about programming. They do chess. But I get it. You're saying, well, I don't have 150 monoliths. Or actually, couldn't you have just done this? So that other approach, that was all talking to one service. That's the multi-tenancy approach. Couldn't we have done a single tenancy approach where we actually deploy 150 services, one for each of our sites, and they are programmed to talk to the correct one? Yes, we could, but then we've got to deploy 150 services. We're trying to make these things simple for ourselves. Multi-tenancy felt the simpler option. But yeah, okay, you don't have this problem. You don't have 150 sites. You don't have many instances of your monolith running. Or don't you? Do you have local environments? Each developer is running a version of their own monolith. So are we saying that, okay, we do single tenancy, every developer and every monolith environment needs to have a version of the service running side by side? Everybody needs to install it on their laptop. What about when you've got 10 services? Does everybody need to install all 10 services for this stuff to function? Now, okay, you can have mocks set up in your monolith so you don't actually need them. Or you can say they fail gracefully so you don't actually need them. These are all valid approaches, but I think trade-offs aside, isn't it just easier to say, well, they can all just talk to the dev service that we host in the cloud? Okay, now you need internet access to run the monolith because it needs to talk to this service. But if you were to do this approach, it's a bit silly that you've got your own local data, you call out to a dev service, and the dev service is then programmed to call back to the dev monolith. And again, you get the wrong data. And this is one of my scars. This is one that I've genuinely seen. Like, we had a company where we had Devo 1 and Devo 2, two different environments, and there was a third-party integration. And the third-party integration was kind enough to give us a sandbox environment, as they do, but just the one. So we have both Devo 1 and Devo 2 talking to this sandbox environment with different data sets. And occasionally, right, so you had to configure a callback URL in the third party. There's your circular reference. They both know of each other. They're both integrating with each other. We do something on Devo 1. It does the thing in the third party. Third party calls back to Devo 2 now. Devo 2 goes, whoa, this user's done this thing. And it blows up because it didn't do the thing. It gets the wrong callback, wrong data. So we don't want that to happen. So hopefully, maybe I've convinced you locally, having it this way around is better, at least, for the development of it, even if not for the production of it. Development, it's better to have it like this. When you have it so the monolith depends on the service, but not the other way around, you don't actually even need your monolith running. So you can now work on moderator messaging in our sense, or whatever your service is that you split out, without even installing the monolith on your laptop. It just works standalone in isolation, because it doesn't depend on the monolith. And what we did in this case, we actually built a slim host, which is just an HTML page, really, that does that empty div stuff. And that means we don't need to be running the monolith. We can just simulate the integration that we have and host it within this slim host. So it makes local development easier. So I'm hoping I convinced you. If I didn't, please do talk to me after, because I know some people disagree with that. But hopefully I've convinced you that this is the direction of dependency you want. The monolith depends on the service and not the other way around. But it's always trade-offs. And if we do that with the software, then what about the data? Yeah, we were talking about data, right? Do you remember? Before I went on a 10-minute rant about circular references, we were talking about how we get the data in the monolith. Let's remind ourselves. This is the data. This is the UI. And we want to get all of that stuff, all of that data into the service. So we've got username and profile. Let's say they're in a user's table in the monolith. And we've got the date and the excerpt. Let's say that's in a messages table in the monolith. This is our data. And we know that because of this circular reference and because of the direction of dependency, we can't, from the service, go and grab that via anything. We don't know it's there. We don't know it exists. So we need to make a copy of that data in our service. Doesn't have to be exactly everything in those tables. So it's the stuff that it needs, its own representation. Maybe it's structured differently just for its purpose. For example, in users, we don't need to know the reputation or how many gold badges you've got. We only need to know the name and your profile picture to display. So that's all we need to send across. So how do we get that copy there? Because we can't pull it. We need to push it. The monolith or your community website or the slim host, something, test data, needs to tell the service, here is the data that you're using. So in production, that is the monolith needs to tell the service. So we have a few times this happens. Once manually, so immediately before going live with the first version, we can go, as developers, we can hit basically an endpoint on the monolith that we can access that says, go and send all of your data over to the service. So the monolith can then package this all up and hit an endpoint. We can give it a date range for efficiency. Hits an import endpoint on the service, says, here's all the data. That's good for testing as well. You can give it some fake data. So that's a manual thing. But we don't want a developer basically sat hitting this button every time somebody creates a new message. So in production, when this is live, we also need an event-driven approach. So when the data changes, the monolith also needs to tell the service, hey, that data has changed. So, hey, yes, I've created a new message. Here is this new message. Go and put it in your representation of the data. But also, the username has changed, or somebody's changed their profile picture. Somebody who has a message in your database has changed their profile picture over here. The monolith needs to go and tell the service, hey, go and update your representation of that profile, of that user. So if you have an event-driven architecture where you've got these events anyway, and you can just subscribe to a username changed event or a user profile picture changed event, and then just send that over to the service, that's great. That's event sourcing. You can have something that is basically sourcing the representation of the data you need in the service through events. You're just saying, well, I care about that, I care about that. I'll update my representation so that when I need to display it, I can just pull it from here. That's event sourcing. And if you're working with events, then there are plenty of other talks on this sort of topic, so I won't go into too much detail, but events or any distributed system where that information is shared over a network, networks can fail. And they do fail. And there are ways around that. So what happens, what you don't want is somebody goes and changes their profile picture, and in the background, that's making a request to this mod messaging service. And let's say the service is down. You don't want it to blow up. You can't have, I can't change my profile picture because the mod messaging service is down. Doesn't even make sense. So you have to deal with that, change the profile picture. A way to do it, or probably the correct way to do it, is there's the outbox pattern. So a transactional outbox pattern, which is basically, in short, the monolith in one data transaction makes the change and also schedules an event to be sent, to be published. Yeah, we should totally do that. That's definitely what we want to do. We didn't do that though either, because again, 21-point story. We don't want to be putting in all this effort. Other teams are going to hit this problem. Maybe somebody else can build that. What we did was we have a schedule as well. Configurable. So every 10 minutes, every half hour, the monolith just goes to the service. Here's all the messages from the last 10 minutes. Here's everybody that's changed their name in the last 10 minutes. Everybody that's changed their profile picture in the last 10 minutes. And the service then just updates its representation. But hidden in all that is a kind of implicit requirement, that we're happy, or a statement at least, that we're happy for this data to be out of sync by up to 10 minutes. If we miss a message, we're saying we're happy for it not to be there for up to 10 minutes. And now we have to talk about eventual consistency, because this is what that is. We've got two databases with the same data, but we're accepting potentially they won't be consistent all the time. Maybe up to 10 minutes. And even the top one, even when it's successful, it still takes a few milliseconds for that request to propagate to the other service. So at any exact point in time, we're accepting this data might not be consistent. And if we were practicing SRE and we were site reliability engineers and we are setting ourselves service level objectives, or SLOs, we can set a freshness SLO for how fresh do we want this data to be. And you should set SLOs, not just random numbers that you've pulled out of nowhere. They should be based on the user experience. So what would the user expect? How fresh does the user want this data to be? And actually, I think in most cases, users are quite content with some form of inconsistency in data. You don't look at your social media feed and expect to see posts from 3 milliseconds ago. You're kind of happy that they might take 5 minutes to display or something like that. Generally, we're quite happy for a bit of eventual consistency, as long as it's eventually consistent. It doesn't have to be consistent right now. And do you remember I said we picked an entry point, and that makes it easier? That's this bit. This makes 10 minutes acceptable. Because if, for example, we didn't pick an entry point, if, say, we picked the view message screen, and you're looking at a thread, then we could have this user journey, if we get these Postits out again, where the user is composing a message. So they've got the text box and they're writing a big essay to the moderator about why they shouldn't have been banned. And they spend a lot of effort on it, and then they go send that message. And this send message feature, the writing part of it, is still in the monolith. So we send that message to the monolith puts it in its database, in its messages table. And meanwhile, that triggers the event. So now we've got number 2 there. That's telling the service, hey, somebody's just made a new message, go and put it in your representation. But at the same time, the user's browser is now refreshing, and they land on the view thread, where they're expecting to see their message that they just sent. But the view thread is now read from the service messages table. And we've got a race condition. We've got a race. What happens first? Can the monolith get that stuff to the service before the user's browser refreshes? Who's going to win the race? And if the monolith loses the race, the user just sees their message has disappeared, which is a horrible user experience. So in that case, and if we were setting an SLO around that, we would have to be quite strict with ourselves. This needs to be really fresh. It needs to be, the browser needs to refresh slower, or it needs to be quicker than a browser refresh. But when it's an entry point, and there is nothing like this that can happen, the worst case is the user manually navigates themselves back to the moderator dashboard after sending a message and goes, my message isn't in the list. And then they refresh the page a few times and it is there. That's the worst case. So, and that's not even a horrible experience. I mean, you just think, oh, it's a little inconsistent. It'll be there. Maybe. So we can be a bit more lenient with our SLO in that case, I think. It's a bit of a better user experience. So that's when we've just moved. So we've moved the one feature across, or whichever of those 2 features. We moved this vertical slice. Eventually, no pun intended, we will have moved all of these to the new service. So now the write and the read and everything to do with messages is all happening directly on the service. Now eventual consistency goes away, or that exact eventual consistency problem. Now we don't have a scenario where it's written to one database, because it's only ever in one database. In fact, we don't even need the messages in the monolith anymore. All the messages stuff is over in the service, and there is no eventual consistency problem with them. It's not distributed anymore. But the user information is still there. The messaging system doesn't own the user information, and it never will. So we will still have potential eventual consistency problems with, for example, somebody changes their profile picture, and then they navigate to a message, and maybe on the message thread, it's just showing their old profile picture for a bit, for maybe 10 minutes. And that's fine. I think that's fine. I don't think anybody's going to raise a bug that my old profile picture took 10 minutes to go in just in that one page. That's fine. I think so anyway. And maybe that user service comes back into play, and maybe the user data eventually, who knows, lives in its own service, in its own database. And maybe in this model, we can pull that data and actually depend on it being available. And then there is no sync, no push that's happening, because there's no circular reference now. But we don't know. We don't know what's going to happen here. And so I just want to end on a note on general pragmatism and these sort of architectural decisions we have to make. We don't know if that's going to be the future. If we go back to this slide, the multi-tenancy slide, and now with our knowledge that we've got there of the data sync and all of these monoliths pushing the data to the service, they're all pushing data with a user ID. So they're saying user ID 123 has changed their name, for example. So we need to store that user ID over in the service. And also, because user ID number 123 on superuser is not going to be the same user as user ID 123 on Stack Overflow, we also have to store the site ID and make a bit of a composite key out of the user ID. So the uniqueness of the user is now these 2 fields combined. And these ideas, user ID being an integer, and site ID, that's genuinely what we call it in our database, or databases that already exist. You could make the argument, and I certainly did try and make the argument, that just knowledge of user ID and site ID is a reference to the monolith, to how it is an understanding of how the monolith is built. And you could make the case that if that's a loose reference, albeit, but a reference, then we've got a circular reference again. The service has knowledge. And I did try and make that case, but you have to concede that our developers know these terms. Everybody that works there knows that a user ID and what a site ID is. Site ID number 1 is Stack Overflow, that sort of thing. Maybe in the future, all of that gets moved into a user service and a site service, and that becomes part of the platform. And maybe it's fine for the service to depend on that because, again, no circular reference. We're just dependent on the platform. We're allowed to have knowledge of users and sites. Maybe, but we don't know. We have no idea, and we're not trying to over-engineer for this. What about your community site? Your app is sending us a GUID instead of an integer user ID. So what, do we have to design the service now thinking, well, user IDs can be anything. They could be strings, maybe. They could be email addresses. But no, of course not. We don't have to don't make silly decisions like that just because of these potential futures. They're guidelines, but you have to be pragmatic. What about when we've got hundreds, thousands of customers that are all embedded our little widget on our site? Now our multi-tenancy thing's starting to look a bit silly, isn't it? We've got 1 million customers all using the same thing. Maybe we should have gone single tenancy then, deployed 1 million different services. But we can't. We can't make those decisions with the knowledge we have today. All we're trying to do is get one tiny, tiny feature, the smallest feature we could find, into production. And then once it's there and we've got a service running, from that point, we can iterate on that. So that's what we've done. And that's all I've got for you today. Thank you very much. If you liked, this goes to my website, if you liked that sort of animated style, I do make little YouTube videos on a channel called Drawing Boxes, so please check that out. Also, that animation to get the QR code to do that took me forever, so please appreciate that. Yeah, I have actually sped through that. I haven't really got, I can do a couple of questions if anybody's got anything, or just find me around and talk. Nothing.
I hate you took the same shortcuts I took.
Well, is that a good thing though? Two people independently come to the same decision. Maybe that backs up. Maybe it was a wise choice.
I was specifically the auth and the proxying through the monolith.
Yeah.
I was like, cool. I wonder if he finds a better, cleaner, quicker scenario done at the same time.
Oh, I apologize. The user service probably is the way, isn't it? But that was too much for our team, not a platform team, just a product team doing this first. We weren't going to do the hard stuff, just quick proxy. Any others? Hello?
You mentioned that in the last scenario, last level you were, user may not see refresh jump before 10 minutes.
Yes.
Why? Because it was event-driven, so once the feature changed, based on this theory, the service should be updated, right? Why did you say it may not be updated accordingly?
Yeah, okay. So why, when it's event-driven and it is going to send the event to the service, could it be up to 10 minutes? Reason being, networks can fail. So even though 99.9% of them are going to go through, and even they're going to go through in, a few milliseconds, there's still a small gap there for it to be eventually consistent. Maybe that doesn't matter because the browser can refresh faster. But in the cases where it fails, for whatever reason, Yes. In the case where that event fails for whatever reason, maybe because just temporary network blip, maybe something blows up, GUID collision, who knows, something happens, it didn't accept the event, the next time it will get that data would have been 10 minutes later.
So it's not a scenario?
Not a normal scenario, so yeah, edge cases. It's kind of saying that you have to cater for it. Networks do fail. You could put retry policies in there, so maybe less than 10 minutes. Maybe it retries a few times over the course of 1 minute. It might get there then. But yeah, it does happen. And if you've got 1 million users using the thing, and it only happens 1 in a million times, somebody's going to see it. You have to cater for it. Any more? Hello? Yeah, duplicate. So how do we manage dependencies from the service that would call back or reference the monolith, such as the user? Yeah, we would. duplicate, well, the user is a funny example because we had our own representation of the user. So yes, it's duplicated, but you can tailor it to your case. And in other examples, other services will also need users, but they'll need different properties of the user anyway. So yeah, each service can have its own representation, its own data model, and it will sync the bits that matter. But the bits that do matter, yes, are just duplicated. It's better than the hard reference, I think. Yeah. The slides, I get asked that. So no, there's a lot of detail, and a lot of builds, lots of animations, but I do try and convert bits of these to my YouTube channel. So there will be like segments. So for example, there's one video on Conways law, there'll be other videos. I do plan on making one about the sequence diagram that I did. So yeah, I try not to give the exact slides away because I then make them into YouTube videos, but on my YouTube is the stuff. Sure. Which? That one?
No, the last one.
Oh, the very last one. Oh god, now we've got to go watch all these again now. Yeah, there's a lot. It's also, I don't feel it will be particularly useful to see exactly all of this stuff and every little detail, every little animation. You'll have to watch through all this again. Once I made a blog post with some pictures on it, maybe I could do something like that as well, like to jog memories. Do you know, why am I doing this? Why don't I just do that? Cool. I think we're pretty much at time anyway. So yeah, thank you very much, dude. Come and chat to me if you want anything.